With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A block of mass m slides down a wedge of mass capital M as shown. The whole system is at rest. When the height of the block is h above the ground, the wedge surface is smooth and gradually flattens. There is no friction between wedge and ground. So, if there is no friction anywhere, the speed of the wedge as the block leaves the wedge is. So, as this block slides down and it reaches this point, it will have acquired some velocity v1, and because there is no friction between the wedge and the ground as well, so this will have acquired some velocity v2. So, and since there's at this point both the velocities are horizontal and there is no external force acting on the system along horizontal, so the linear momentum along horizontal can be conserved. So what that means is m1 v1 should be equal to m2 v2. Let's mark it as equation number 1. Now there is no friction anywhere, so there is no energy being lost, so the total mechanical energy is also conserved for the system. So if I write the total mechanical energy, so initially the total mechanical energy would be, for this block it will be the potential energy, so m g and height is given h, plus there is no velocity to this block, so 0, plus the energy of this wedge, there is no velocity and it is not at any height, so that would be also 0. Now the final the total energy of the system will be the energy due to the velocity of this mass m, so m half m v1 squared, plus the kinetic energy of this wedge, so 1 by 2 m v2 squared. This should be capital M because this is for the wedge. So this is equation number 2. Now if I go back to the equation number which was m1 v1 is equal to m2 v2, this gives me m v1 should be equal to capital M v2, which gives me we have to find out the velocity of the block. So I will substitute v2. So v2 is equal to m v1 by capital M. Now let's substitute this into equation number 2, which is mgh is equal to 1 by 2 m v1 squared plus 1 by 2 capital M v2 can be written as m v1 by capital M squared, which gives me mgh is equal to 1 by 2 m v1 squared plus 1 by 2 capital M square v1 square by capital M squared, which gives me mgh is equal to 1 by 2 mv1 squared plus 1 by 2 m squared v1 squared by capital M, which means v1 squared is equal to mgh upon 1 by 2 m plus m squared by capital M, which means v1 is equal to root 2 mgh upon m plus m squared by capital M 1 by 2, which means v1, there should be a 2 here, which v1 is equal to root 2gh upon 1 plus m by capital M 1 by 2. If we look at our options, so we need to simplify this a little further. So v1 is equal to root m 2gh H by M plus M, which gives me V1 is equal to, now I'm going to multiply by capital M in numerator and denominator. So in the numerator it will become M square and I can bring it out of the root. So M times root of 2gh upon M times capital M plus M. So this is our answer, and if we look at our options, so correct answer should be, and the question asks about the speed of the wedge, not the block. So I'll have to, the speed of the wedge will be V2, which is equal to mv1 by capital M. So M by capital M times V1, which is the expression that we just found out, M plus M, this get cancelled, so M root 2 gh upon capital M, M plus M. This is V2, so our answer should be option A.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.